In the last video, we introduced metric unit prefixes and looked at different ways of converting units just using the definitions of the prefixes and that logarithmic scale. This video is going to focus on a third way of converting units, and this one is slightly more mathematical, and to me, I like it a little bit more just because, math, yay math. And so this method is called dimensional analysis, and so you're going to see this all the time in your chemistry class if you haven't already. The idea with dimensional analysis is that you're going to start with your unit, and then you're going to multiply by a convenient form of 1. Okay, so this is really just saying 1. Okay, we're saying that they are the same thing. And so same thing. Okay, so for example, using the imperial system for a minute, if we start with inches, right, we know we can convert inches into feet by dividing. Okay, so if we have 24 inches, we essentially divide by 12. This is what we do in our head. We just don't show it mathematically. Take 24 inches, divide by 12, and then gives us 2 feet. Okay, when we do that, we're actually multiplying by this ratio of 1 foot to 12 inches because these are the same thing. Okay, we know in 1 foot there are 12 inches. Those measurements have been defined to be the same. Okay, and then what happens mathematically is that the units cancel. If you think about them as variables, that might help. And so if we want to cancel inches, and we know inches is currently present in the numerator, well, we need inches in the denominator, and then our equivalent unit goes in the numerator. Okay, so this might take a little bit of getting used to expressing it in this form. You might just be used to doing it in your head and not showing the mathematics, but we like to see the work. Okay, so we're going to do 2 examples, and I'll leave them both on the screen here. I encourage you to pause the video, try them on your own, showing all the work, and then resume the video. Alright, well, hopefully you were able to pause the video and take a shot. And so what I would do here, okay, first of all, I prefer working in scientific notation. So this is 2 times 10 to the third centimeters. Okay, and so then to convert to kilometers, okay, so I know that centimeters on my scale is at 10 to the minus 3, kilometers is 10 to the third, okay. I'm going to show you 2 ways of solving this. There's one that's kind of a more direct way, and then one that's a little bit longer, okay. So let's say I don't really remember how many centimeters are in a kilometer, that sort of thing, but I do know that say if I convert from centimeters to meters, I know that there are 10 to the second centimeters in 1 meter. Okay. Now the reason I put centimeters in the denominator was because the centimeters that I began with was in the numerator, and so this allows me to cancel the units of centimeters. Okay. Again, thinking of the centimeters as a variable as well as a unit. Okay. And so this is an equal amount. Okay. Now if I do the math here, I'm going to be left with meters. I want to be in kilometers. So then, so then I can continue multiplication and say, okay, well, in kilometers. So if I convert meters to kilometers now, that one's a little easier for me to know. I know in 1 meter there are 10 to the third kilometers. Okay, other way around, JK. In 1 kilometer, one big thing, there's 10 to the third meters. Okay, so then at the end of the day, I can then cancel meters as well, and when I press forward, all I have to do, since it's multiplication and I have fractions, multiply numerators, multiply denominators. So in the numerator, I'm left with 2 times 10 to the third. In the denominator, knowing that I have these exponential expressions, I would add the exponents, right? We're really good with that. I don't know what's happening in my pen. It's freaking out. Okay, and then this would be in kilometers. And again, simplify all this, reducing these, and I would just end up with 2 times 10 to the minus 2 kilometers. Now, again, I don't really like negative exponents, but this is scientific notation, so I just have to deal with it. Okay, and that would be my final answer. Okay. Now, for some of you, you may not need to do this much work. You could just say, okay, so here's the other shorter way. You could do 2 times 10 to the third centimeters, and then you might be able to just convert right from centimeters to kilometers and say, well, using my little ladder there, that scale, that logarithmic scale, I know that there's 10 to the 5th centimeters in 1 kilometer, and then you get to the final answer a little bit sooner. Okay, whichever way you prefer to work, hey, great, do it. Okay. Next, this one. So again, I like scientific notation. 1.5 times 10 to the minus 2 deciliters. Okay, and so now I need to convert to the microliters, and now for some reason I always have to look up deciliters because we don't use it that often, but it is a unit that I'm asking you to know. This is at 10 to the minus 1, and this is at 10 to the minus 6. Okay, so deciliters to microliters. And so now, again, maybe you're the type of person that needs to go to the base. So maybe you need to do deciliters to liters, and then maybe you need to do liters to microliters. Okay, and then so again, all that would cancel. Okay, I'm gonna say, well, I'm feeling pretty good today. I can go straight from deciliters to microliters. Okay, so now I'm going to say in 1 deciliter. Okay, so if I'm starting up at the deciliter spot, there are 10 to the 10 to the 5th, 10 to the positive 5. Okay, so deciliter is larger. You need to break deciliter into many smaller things, microliters, and specifically 10 to the 5th. Okay, now, and then you can multiply through. Okay, I'll do the multiplication in a minute. Here's a question I want to pose. Can I also say that maybe I remember, well, 1 microliter smaller, and on the scale, they're 10 to the minus 5 apart. Okay, is this okay? And my answer is yeah. Right? Because you can, by laws of exponents, right, you have negative in the exponent here, you can make that positive in the numerator. Okay? Either way, your call. Okay? But anyway, carrying through here, multiplying across, and again, you can always insert a 1 in the denominator if that helps you. Multiplying across, I get 1.5 times 10 to the positive 3 microliters. Okay, so this is a little bit of dimensional analysis. We will get a lot more practice with this, both in class next time and the time after that. We're going to spend a few classes on conversion with units.